Hi everyone. So this is the part two of our solving non-right triangles. And we're going to look at the scenario when we need the law of cosine. Now you might recall in the previous class that we had different cases. Angle side, which is the same as side angle, and then there was angle side angle. These were solvable by the law of sine. Now actually there's another case too, the angle side, which is the same as side angle. All of these are solvable by the law of sine. But the ones that we didn't study are the two-sided cases where the angle is in between them. So that would be side, angle, side. And another one we didn't study is, what if we have all three sides? Can we find all the angles? And it turns out we can. But these two cases are solvable by the law of cosine. So that's our game plan for this lesson here, is we want to develop the law of cosine, and then we want to apply that on a couple of our problems. So first of all, how's the law of cosine going to work? Well, I'm looking for ultimately a formula. I want a formula that is based on A's and B's and C's, or angle A's, angle B's, angle C's, and that's it. Some kind of formula about this triangle, and it only has A, B's, and C's in it. Now we have a problem with that, because if A, B, and C, these angles, are not 90, then I don't have access to my regular trigonometry. So to create a formula where A, B, and C have no 90s, we've got to do some tricks here. And I'm going to do the same trick that I did last time. I'm going to introduce h, the height. Now, because I have a height in here, I do have a 90 degree. And so I can start incorporating some 90-degree trigonometry stuff. But that's going to require an h, and I don't want h in my formula, so eventually I'm going to have to get around that. Also, I'm going to incorporate a distance here, x. And with that, I'm going to start creating some equations of triangles and trigonometry that I know to create a new formula that has only A, B's, and C's in it. So first off, though, I can see something kind of straightforward, that I got a triangle here. So b squared is the hypotenuse of this small triangle. And so that will equal the Pythagorean theorem. B squared equals h squared plus x squared. Okay, now I'm going to further isolate this other triangle. Okay, so I have a triangle over here too. And it also has h in it, has a on it, but I don't know this side. However, the whole side is c, little c. So from here to here is the side little c. And this side is x. So that means this little piece here has to be equal to the distance c minus x. And so actually I have at least a formula for all three sides of this orange triangle. I'm going to use that to make another equation. A squared equals h squared plus c, I need c minus x squared. Okay, now I'm not getting too much traction yet on my goal. I want equations. I want a formula for this triangle. And I want to make assumptions that A, B, and C are not 90. Now I do have assumptions that are 90, but they're based on this place where H touches down. That's getting really congested there. Okay, so, however, I'm going to start simplifying a little bit, and I see something here that might clean up. A equals H squared. I want to FOIL, so I'm going to have C squared minus 2CX plus X squared. And I'm noticing H squared and X squared. Hey, H squared plus X squared is equal to B squared. I can take these out. I left off the square. A squared equals, I'm going to take this out and replace them with B squared. Because B squared equals H squared and X squared. Okay, so that still leaves me though with a little bit more. C squared minus 2CX. Now this has, with that one substitution of plugging, I plugged in equation 1 into equation 2, and I got this outcome here. Now this is taking shape into becoming a formula. It's a formula about my green triangle that only has A, B's, and C's in it, except one little hiccup. It has this X, and I don't want X because it's not part of the non-right triangle. So I need an expression for X. So let's see. Let's go back to the triangle and see if we can figure out what X is. I'm going to come up with a new equation. Well, I have X and B and A in this right triangle here. So I'm still going to use that right triangle idea, but that is the adjacent. So I know that cosine of A equals X over B. So X equals B cosine A. Okay, I can substitute this in and plug this in right here. So when I do that, I'm going to get an equation. Orange may not be the best color, but that's what I've got now. Oh, I got red. No, I'm not doing red. I'm going to keep the, at least to keep it the same color that it was originally. So, A squared equals B squared plus C squared minus 2 times C times X. But I'm taking X out and replacing it with B cosine A. Okay, now I'm just going to do one tiny adjustment to organize this part of it a little bit. And we're going to have A squared equals B squared plus C squared minus 2 BC cosine A. And we have here an equation. And this equation is about my triangle. And my angle A is not 90 degrees, and it does not depend on B or C being 90. I have no 90s in that triangle. And so this gives me a nice equation, and it is called the law of cosine. Now, the law of cosine, the way I solved it here, I just kind of focused with H going down in this direction. But I could have put H in other directions, and it would have given me a parallel version of the law of cosine. And those parallel forms are instead of a squared, it would start off with b squared equals a squared plus c squared minus 2ac cosine, there's where it gets its name, the cosine of b. So if it equals b squared, then the angle I plug in is b. And a similar version of this, let's do blue, would be c squared. And you can kind of start seeing there's a parallel relationship between the three formulas. And so really the three formulas are just one formula. They're just different variations of the same thing. But c squared would be a squared plus b squared equals 2, not equals, minus 2 BAB. And then it's going to be cosine of big angle C. I'm going to make this smaller. So if it equals c squared, side c squared, then it's going to be angle C. If it equals b squared, then it's angle B. And if it equals a squared, it's angle A. And that's how you can kind of see the configuration to set up for it. It doesn't really matter because we can just move these letters around, whatever letters we want. So really it's one law that we can write in different ways. Now this law is great for problems that are side, angle, side, or three sides. If we have this kind of data, if these are the cases for our data, then we can solve with this law. In fact, let's practice this. Okay, so I'm looking at a triangle and I want to figure out, because a law of sine is easier than the law of cosine. The equation for law of cosine is slightly more complex. So if I can do the law of sine, I want to do the law of sine because that's a little bit easier. And as I look at this data here, I'm seeing, I'll just leave that. I have a side, and then I go to an angle, and then I go to a side. So this is side, angle, side data, which definitely fits with the law of cosine. So if we're going to solve this triangle, we need to start organizing what we got. So I need to solve for A, B, C. These are angles and sides. A, side B, side C. And side C is known, that's 8. Side B is known, that's 4. Side A is missing. I'm going to have to find that number. Angle A is known, that's 46 degrees. But angle B is missing. I'm going to have to find that angle, and I'm going to have to find that angle. So I have two angles that are missing. Now, the great thing about law of cosine, it's really easy to plug in. But you are going to have to be careful when you plug in and use your calculator. But let's go after the side A. That's my first goal. So I'm going to go right to the law of cosine. A squared equals b squared plus c squared minus 4, minus 2 bc cosine A. Now, I know b and c, so all this is just plugging in. I know everything here. A squared equals b squared. Well, b is 4 squared plus 8 squared minus 2 times 4 times 8 times the cosine of 46 degrees. Just 100% plugging in here. And so the rest now is calculator work. Okay, I got the calculator ready to go for us. Now here you have to make some decisions. You can type the whole thing in the calculator and go in one step. But that's kind of high stakes because one tiny flaw in your calculator button pushing and the whole thing is wrong. So some things you could do is do parts of it, like this part over here, 2 times 4 times 8 times cosine of 46, and just get one value for that. So if we did 2 times 4 times 8 times cosine of 46, and we'll get a numerical value for that part of the graph. Now I would leave this whole number in the calculator, 44.4581, and when I continue my next step, I'm going to do the next step with that whole number. But I'm going to be lazy when I write on paper, and I'm going to round that off on paper. So theoretically, though, we do not round off until the very end. So when I do my next step of math, I'm going to use this long number for the next step of math. But I'm going to write it down as 44.5. This is just a round off answer over here. And so we're going to be able to do a squared equals, and that's 16. That's 64 minus 44.5. Now this is lower stakes because I'm showing my intermediate steps on the calculator. I'm not going for the whole thing in one shot. Little safer so that I can see your steps and know that you're doing everything right. Even if there's a calculator error, I'm seeing steps, so I'll be able to give you more partial credit for that. And so, in fact, we could finish that off and go 16 plus 64 minus, and then we'll go up and grab this whole number and put that whole number in there and enter that. And so that's going to be a 35 point, it equals 35.5. So that's a squared. So a squared is 35.5. Now this is a round off here because I'm basing it on just rounding off. But I want to get the exact answer for A, and I'm going to take the square root. So I'll take the square root, and I'll be done of this whole answer and enter that, and I get a 5.96. Now it did say round it off to the tenths. So the 9 is in the tenths place, but the 6 after that says round it up. So this is going to be a 6.0 centimeters. So we just found the side is 6.0 centimeters. Okay, next we need the angles. And so I'm going to use the law of cosine again to find the angles. Now, if you're great at memorizing formulas, read the book, because it does have the cosine by itself, and it's a second version of the law of cosine. But I'm not so great at it. I can memorize this first one, and I'm going to use that version of it to find, but I want to find B. I'm going to find B next. So if I'm going to use B, then I need the B squared equation. B squared equals A squared plus C squared minus 2AC cosine of B. And B is what I don't know, but I know everything else. So I'm going to use 4 squared equals A squared. And I just found A. It equals 6. And C was given to be 8. And 2 times A, now A we just found was 6 times C, which is 8, times the cosine of B. And I've got to do a little bit of algebra here to get this equation isolated. Now be careful on the algebra, because the signs are going to require some rearranging. So I'm going to add this thing to the other side on both sides. And in fact, we could maybe simplify this before we start doing algebra. In fact, that's smarter. 16 equals 36 plus 64 minus 12 times 8. 96 cosine B. And 36 and 64 is 16. That is 100 minus 96 cosine B. Okay, so let's get cosine by itself so we can solve it. So I'm going to add 96 cosine B to both sides. But I'm also going to minus the 16 from both sides. That's a little sloppy, sorry about that. But that's going to give me 96 cosine B equals 100 minus 16, which is 84. Now I'm going to divide by 96 on both sides. Alright, so I'm almost there. Now we've come back to chapter 9. It's come full circle. We've got to solve a cosine equation. 84 over 96. And I'm sure that's reducible. But I'm not going to worry about reducing it because I'm just going to use the inverse cosine. It's a positive ratio. And cosine inverse will answer in quadrants 1 or 2. So it'll be something smaller than 180, which is exactly what I want for a triangle, angles less than 180. So B will equal the cosine inverse of 84 over 96. Oh, let's use this calculator so you can see. Cosine clear, no, not cosine. Cosine inverse 84 divided by 96. Close that. And I get a 28.95. And since we're rounding off to the tenths, 9 is in the tenths place, but the 5 after that is going to round that up to 29.0. So we can just call that answer 29 degrees. So B equals 29.0. We found the second part, 29 degrees. And C, the angle C is easy. I mean, we might as well, if we know all the angles add up to 180, then we can just subtract 46 and 29. So 180 minus 46 minus 29. And that gives me 105 degrees. So I've got the whole triangle solved. And this is using the law of cosine. I used it twice. I used it here once to find my side A, and I used it a second time to solve my unknown angle B. It's just a lot of work in the calculator, basically, once you start plugging stuff in. All right, let's try another one. This one, I solved the triangle, so it's really a repeat of the previous problem. We got to solve all the parts. So we need angle A, B, and C. And we need side A, and side B, and side C. Okay, so actually B we know is 4 feet. A we know 6 feet. C is missing. The angles, we only know one angle. No, this is 96 degrees. Oops, I don't want to circle that. So B is missing. I'm going to have to find that. And A is missing. I'm going to have to find that. All right, so let's go after the side here, side C. So we can use the law of sine. Little c equals a squared plus b squared minus 2ab cosine of c. I'm going to make my side c a little smaller for lowercase. And now I'm just going to plug in everything. So c squared equals 6 squared plus 4 squared minus 2 times 4 times 6 times cosine of c, which is 96 degrees. Okay, so here's what I mean by the calculator can really solve the whole thing. Now this is a little bit of risk, but I'm going to show you anyway just so you can make your own choice on this. But we can plug this entire expression into the calculator and just do the whole thing in one shot. 6 squared plus 4 squared minus 2 times 4 times 6 times cosine of 96. Now I typed in a whole bunch. Is there a risk I typed in a number wrong, a sign wrong? Yes. So the more I do in the calculator without showing steps, I take a little higher risk, because if this one statement has one thing punched in there wrong, then that whole answer is wrong. But now I got c squared. C squared is approximately 57. When I finish it off in the calculator, I'm going to do the square root. But I'm going to do the square root of the entire original answer. And it'll be a little bit more accurate. And then the real round off will come at the end here. And we want to round it off to tenths. So 5's in the tenths place, that's 5, 5, so it's going to be c equals, I forgot what it was already, 7.6. All right, so we found the length here, 7.6 feet. All right, now we need to find an angle. It doesn't matter which one we find, A or B. I found B last time, so let's find A this time. Now, if I want angle A, I need the cosine A equation. So that would start me off like this. A squared equals b squared plus c squared minus 2bc cosine of A. So now I can focus on cosine of A, because I know all the other things. I know the sides A, B, and C. So I'm going to plug all those in. So 6 squared equals 4 squared plus 7.6 squared minus 2 times 4 times 7.6 times cosine of A. And now I want to start cleaning this equation up here. Now the 7.6 decimal is going to make the math a little harder, but not too much. The calculator can handle all that. So, but let's move all this stuff over. So here I'm going to solve this one slightly different than I did before. Oops. Okay, so I'm minusing 4 squared over here, minusing 7.6 squared, and that's going to leave this expression by itself. And then I've got all this math to do over here. And so let's let the calculator figure out the left side of my equation. So that will be 6 squared minus 4 squared minus 7.6 squared, and I get a negative 37.76. While we're at it, let's multiply this part of the cosine 2. It's 2 times 4 is 8. 8 times 7.6. Enter. 60.8. Now the calculator disappears, so I have to remember both of those numbers. I don't want to mess that up. So 37.76 and 60.8. So when we did this math over here, the calculator told us that it was negative 37.76 equals. And when we did this math here, the calculator told us that is the minus is still there, so it's a minus 60.8 cosine of A. Okay, I'm really close now. I want to find A, so I have to isolate cosine. So that means let's divide negative 60.8 on both sides. And now I like to have cosine over here on the left. Negative over negative will be positive. So 37.76 over 60.8. And 37 over 60 is less than 1, which is in the right range for cosine. So it's the right domain for the cosine inverse. Has to be between 1 and negative 1. And cosine inverse also answers angles in quadrant 1 or 2 between 0 and 180, which is perfect for solving a triangle, because triangles, their angles are between 0 and 80, or I guess between 1 and 80. So let's have the calculator find that inverse for us. Cosine inverse of 37.76 divided by 60.8. Close that off, hit enter, and I get 51.6 degrees. So A equals 51.6 degrees. So I found the second of my unknowns. And now I know 96 and 51.6 have to be subtracted away from 180. And then I will have all the third angle. So 180 minus the 96 minus 51.6. And I get 32.4. And I finished the solution to that problem right there. Okay, so you can see the law of cosine. It's pretty easy. It's straightforward. It's a little bit harder to learn than the law of sine, but it's actually pretty straightforward to use. You're just plugging in information here. So now let's do one more case of just an abstract solving of triangles. What kind of data is here? This one, the data is side, side, side. And the law of cosine solves side, side, side. So what we need to do is find the angles. So on this question, let's do angle A. Angle A is unknown. So I need a cosine of A in it. So that would be A squared equals B squared plus C squared minus 2BC cosine of A. There I go. I can solve for cosine A if I just plug in all the other stuff. So side A is 6 equals B is 8 squared. C is also 8 squared minus 2. B is 8. C is 8. Cosine A, unknown. So this 36 equals 64 plus 64 minus 2. 64 times 64 I could have done some more in my head, but I won't. Oops, I wrote that wrong. 8 times 8 is just 164. 36 equals, this is 128 minus, it's just a coincidence. We have all these 8s in here. But 2 times 64 is 128 again, times the cosine of A. Now, I want to get A by itself, so I simplified the equation a little bit, and I'm going to minus out this 128. And then we get the 36 minus the 128 is negative 92. Negative 128 cosine A. I'm really close now. All I have to do is divide. I want to divide a negative 128 on both sides. And so when I do that, I'm going to throw the cosine A onto the left side. And the negatives cancel out. That's just a nice coincidence here. So A will equal the cosine inverse of 92 over 128. Let's see what the calculator says. Cosine inverse of 92 divided by 128. Close the parenthesis. Now I'm starting to wonder if I remembered those numbers right. Yeah, 92, 128, we're good. Let's enter that. And we get a 44-degree angle. Okay, so angle A is 44. Okay, now we also need angle B and angle C. So technically, if you weren't observant with triangles and stuff, you could just use the law of cosine again, and you would be able to find the other two sides. So, but I want you to observe something here. We're going to do a little bit of a shortcut. The two sides, B and C, are both 8. That makes this shape called an isosceles triangle. And so if B is 8 and C is 8, that means angle C has to equal angle B. That's a law in geometry. Now you may not have noticed that, and that's okay. Then you just use a law of cosine for a different angle, like cosine B, and do the law of cosine again, and you'll get it, and then you can find C. But there's a little bit of geometry in here that does make our life easy here, that C is the same as B. Since the sides are both the same, then the angles have to be both the same. Just for simplicity, I'm going to call them both x. So that means 44 plus x has to equal 180. And so if I minus the 44, 2x has to equal 136. Divide by 2, x has to equal 64 degrees. So they're both 64. And then we could do the math really quick to check that. And it is messed up. Something's wrong. Because I didn't divide right. 136 divided by 2 is actually 63. And so now we should add them all up and see, do they really add up to 180? If we add them all up, 3 and 3, and that's 6 and 4 is 7, carry That's 10, carry 1, 12, 13, 14, 15, 16. Nope, it's not working out right. I did something wrong in my math here. 180. 180 minus 44. That is 136. Divide by 2 is 68. Okay, so if I could just do math, I would be better off. So 68 is my solution. And so this, let's check now, especially because I screwed up here. I'm really concerned. I want to make sure I got all that. And think about this thinking is important. So we can check real quick though. So 44 plus 68 plus 68, all that should add up to 180. And it does. So we know we've got our solutions here. And so these two angles had to be the same because their opposite sides were equal. That's just a little geometry shortcut. Don't get bogged down on that though. The big thing to be able to do is use the law of cosine to find an angle or a side. And if you don't know those geometry principles, then just use the law of cosine again. All right, let's do some application problems here. We're looking at a satellite. The satellite is in orbit in Earth's atmosphere. It's flying by. It measures the distance to two buildings. And as it measures, it can calculate the angle in between. And we're supposed to find the distance between the two buildings. So this is the distance between the two buildings. So we actually have a triangle here. I know a distance, and an angle. This is side, angle, side. So side, angle, side is solvable by the law of cosine. And I can find D here with that. Now, if I call this D, then I have to change the formula so it doesn't have A, B's, and C's in it. It's going to have D in it. So maybe we should call this A and B, and this will be angle big D. Big D angle is opposite little d side. And then I can make my equation with the law of cosine. So I'm just adapting the formula. D squared equals A squared plus B squared minus 2AB cosine of big D, because angle D is opposite side D. And the rest is just calculator work. So I'm going to plug in 370 squared plus 350 squared minus 2 times 370 times 350 times the cosine of D, and D is 2.1 degrees. And so now it is a ton of calculator work. So some of this, I'm not going to pull the calculator up for it. Let's see, I was talking about high stakes. I could slam that whole giant equation into the calculator. And the calculator would do it all, provided I typed in every single thing correctly. But to keep the stakes lower, you could show me partial steps. And if I see your partial steps on track, even if one thing got typed into the calculator wrong, I could still give you a lot of partial credit. But they are pretty big numbers. It's tempting here to not mess around with it. It's so, everything is such large numbers. But let's deal with it. We're going to have 136,900 plus 122,500 minus 2 times 370 times 350 is minus 259,000. But don't forget, it's times the cosine of 2.1. So this is not like terms. I have to multiply this before the adds and subtracts. And so when we could clean this up a little bit, I'm going to subtract these first two numbers that are like terms. So these two are just numbers, so I can just subtract those numbers. All right, I have two like terms here that I can add. They're just constants. And when we do add those numbers, we're going to get, let's see, 259,400 minus 259,000 exactly. But don't forget, this second term is times the cosine of 2.1. So we have to multiply the cosine here before we do the subtraction. Do multiplication before subtraction. All right, let's go in and let the calculator finish this guy off. So we had 259,401, and I get this number 573.9. Let's just call that 574. 574. That is what d squared equals. 574. So d is going to equal the square root of that. And so we'll round that to, it's like 23.9. 23. So let's just call that 24 kilometers. So the distance between these two buildings is 24 kilometers. So that's kind of far apart. I'm not used to the metric system, so I don't have a good sense of that, but it seems like a big distance. But that's something we found out from the triangulation calculations in the satellite data. Let's look at one more example here. Now notice we're going to have to use the south 12 degrees west notation. We got to use that direction notation, so we got to be careful about our drawing here. And so over here to the side, let's start drawing. Two ships are at a harbor. Two ships leave a harbor at the same time. All right, so let's put the harbor right in the middle of our compass. And so one ship travels at a bearing of south 12 degrees west. So 12 degrees. Here's west, here's south. And if we were in class, I would take a quick survey and say, oh, okay, 12 degrees. It's about like that. Or wait. 12 degrees is also like that. So that's 12 degrees. This one is 12 degrees. And then I would say multiple choice question, choose. Is it A the answer or B the answer? And we would have a quick discussion to find out which one is which. And I hope in your mind you're able to choose one right now. And I hope you're choosing B because A is incorrect. I did not start, when we do the bearings, we start on the south or the north. And B started off the south and went west. So just to kind of double check and reconfirm your skills there on drawing, we need it to be more close to the south in this case. All right, now this ship, it went 14 miles. Did it go 14 miles? No, 14 miles per hour. That's its speed. Well, how far is it going to go? Well, it does say that it's traveling. If we read a little further, it says this is after 3 hours. So it's going 14 miles per hour for 3 hours. So we're going to have to multiply 14 times every hour. And that turns out to be a 42-mile journey. So the ship has gone 42 miles, and the bearing is south 12 degrees west. However, there's another ship in here, and the other ship is going on a different bearing. It is going on north, 75 degrees east. So here's north, and I'm going to the east, and I'm going 75 degrees, so quite a far ways over here. And it's going 10 miles per hour for 3 hours. So that's a shorter, it's gotten further. It's only gone 30 miles. And what did we say? This was a 75-degree direction. Okay, now, what are we faced with? It says, how far apart are the ships after 3 hours? So maybe one of the ships has put out a distress call or something, and so we have to find this distance here between the two ships. And so if we can get enough information, we can solve that triangle. So let's start putting together what we know. That is not working there, it's too small. But this part is 12 degrees. Okay, I know two sides of a triangle. Now this is a little congested for me, so when it gets like that, sometimes I just draw the triangle all by itself without all the extra information. And so I know this is 30, I know this is 42, and I know this is D. And I'm trying to find D. And I don't have any, I need one more thing, I need an angle. Now all I got is this 12, but that's not a whole angle, that's just a little piece from the south direction. But between south and east I have a 90. Wait, so if I have a 90 and a 12, all I need is that piece there. And this piece here, I can also get because this red piece in 75 has to add up to 90, so that makes this piece a 15 degree. So let's call this angle D, and angle D is going to equal the 12 plus the 90 plus the 15, which is 90, 110, 117 degrees. So now I know everything I need about this triangle. I have side, angle, side data. And so I can use the law of cosine again on this one. So D squared will equal 42 squared plus 30 squared minus 2 times 42 times 30 times the cosine of 170 degrees. So D squared equals, alright, so now you guys make your decisions about how much risk you want to take with typing in the calculator. And so I'm going to type the whole thing. Just on the last one we did all the steps. On this one, let's try it by a shorter way with letting the calculator do everything. Minus 2 times 42 times 30 times the cosine of 117 degrees. I'm sorry I've covered up the problem, but I hope I remember the numbers. In fact, I'm pretty sure I did. 42, 30 squared, 2, 4, 30, cosine 117. Yep, so that is the whole thing. Enter that. And we get this large value, 3,808 0.05. That's kind of small, especially since we're talking about miles. I'm okay with rounding this to whole numbers, so we'll just go 3,808. But I need D. So we'll just take the square root of that. And so we can finish this. We'll go square root, oops, quit. Let's get back where I want to be. Square root of that answer. And it turns out to be 61.7. Yeah, let's just leave it at that. We'll call it 61.7 miles. So if one of the ships has to turn around or turn towards the other ship to help it out, they know they have to go 61.7 miles. So there you go. That is the whole lesson for 10.2 in a nutshell. The law of sine and the law of cosine. Practice lots of examples on this. There's some bookwork examples and some Newton examples. So study hard on these two. This will be really close to wrapping up our whole course. We just have one more lesson after this. Okay, study hard, and I'll see you in class.